if you didn't slow down, it would, the acceleration would be positive.
If we didn't slow down at all, or we just, then it comes down to, all right, I'm walking in the negative direction, let's assume my velocity stays constant. What's my acceleration?
Constant? 0.
There we go.
What did you say? What's your velocity?
I think, in my mind, I asked what's the acceleration. So I'm moving in the negative direction at a constant velocity. So my velocity does not change. So my acceleration would be,
0.
yes. If velocity doesn't change at all, acceleration is 0.
Straight back.
All right, let's see if I at least broke the trend of not answering the question. Did I come close to answering your question?
Yeah.
Okay. Other questions? Have any of you watched the ball problem video? Balls thrown into the air? If you look at some of the, I think it was like the first 2 or 3 tests, this was a test problem. The test problems have gotten more difficult, or complex, I should say, not necessarily difficult. We've gotten beyond it. But let's start out with what I don't consider a test level question anymore. A ball is thrown into the air, can go up and come down. Now I've drawn it slightly separated there just for the sake of the visual here, but the ball is just going straight up, straight down. I'm not worried about any side-to-side movement. No air resistance. What I care about is from the moment after the ball leaves the hand, so I don't care about the hand at all. No Jedi powers, the hand is not going to affect the ball once it's in the air. And I have a ground down here. I'm going to label 4 moments in time. A, B, C, and D. These are moments in time. So A, the time just after ball leaves hand. B, the time ball is at peak. C, time ball is back, preferably right with a D there, is back at starting point. But moving down. And D, the time just before touching the ground. So in this problem, I'm not dealing with it. I'm not dealing with the ball in the hand, and I'm not dealing with the ball on the ground. This is just after it leaves the hand to just before it touches the ground. So we all have a common reference. I'm just going to make the ground 0. Making that my origin, and I'm going to make up positive. So a question like this, what I would like to know, we have the 4 basic characteristics. We have position, displacement, velocity, acceleration. And I'm going to make a little note to myself because there was something I forgot to mention earlier. We don't need it for this, but I want to make sure that I talk about it when we're done with this. So that note in the corner is just for me. So I have position, displacement, velocity, and acceleration. Those are the four major things that we care about. And I want to know, where is it positive, negative, 0? Positive, 0, negative. And I basically have a grid here. Now there's a PowerPoint associated with chapter 3 where I go into 3 or 4 different ways of displaying this information. So just be aware this is not the only way to express it. So let's just start out with what I'm going to call a simple one. Where is the position during the time that during the time of the problem from A through D? Is the ball ever at 0? All right, I heard 2 people express it, although probably more did. There's at least 3 people. So I'm just putting in A there because the ball is never at 0.
Is it not at 0 when it hits the ground?
That's after the problem.
Okay.
Problem ends just before it touches the ground. Problem starts just after it leaves the hand. Yeah, the impact in the middle of the problem, don't worry, we'll get to it. All right, what about, is the position ever negative?
Yes,
Yeah.
When?
and it goes down. It doesn't go
After
afterward.
It would have to be underground.
It would have to be underground. That the position is, where is it relative to 0? 0 is down here. If position is 0, only if the ball hits the ground and sinks into it. That's after the problem takes place. So the ball is always on the plus side of 0. Now, how do you actually write that? You could just write always in this particular case. I'm going to introduce potentially new notation for some of you, because it's the entire time from A all the way through D. So I'm just going to put a little bracket there, write A, comma D. And what that is, that's just shorthand for saying from the beginning of the problem to the end of the problem, because A and D are the beginning and end. And the brackets mean I'm including A and D. I could also have done it this way. Let's see, we have A, B, C, 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 D, D. So those are all the segments right there. Let's sort of put a division symbol in here. My position, it's positive the entire time, so I could also just put plus signs. So A, B, C, and D are very specific points in time. This thing right here where I have the A and B in parentheses, not brackets, but parentheses, that means the time between A and B. The ball's at A, it doesn't suddenly appear at time B. It doesn't transition between it. So another way of expressing the exact same thing as I have over there. And now some stunning visual effects. Yeah. Where is the displacement equal to 0?
C.
I heard C. Okay, anywhere else?
A.
Yep. At A and C, A is the start of the problem, so that better be the starting point. And C, it's at the exact same location. So over here, if we do displacement, it's 0 here and 0 here. Where is it positive? Where's my displacement positive? Okay, so I heard B. That is true. Anywhere else?
I'm gonna say A through D.
Yeah. Not only is it at B, but it's also in between A and C. So over here, I can just write with a parenthesis because I'm not including A and C. A, C. And that's just saying it's positive from A to C, but not including A and C, because that's where it's 0 again. And then where is displacement negative? Oh, sorry, Kimberly, question?
Why is it, B positive?
Because I said A through D,
Oh, you said D?
yeah.
Oh, C. I thought I misheard. So your question is why is D not positive?
Yeah, it says like, it says all of that is positive, so that's what
This gets into the distinction, the difference between position and displacement.
Position.
Right now, I'm looking at displacement. Because I didn't stick an adjective in front of it, we're talking overall displacement. So the ball starts here, that's my starting point. My displacement is positive when I'm on the plus side of that, and it's negative when I'm on the negative side of that.
Oh, that's what we were talking about right there, when you did that.
Yes,
Okay. So since D is not, part of the, C got right back to where A was at, basically,
yeah.
yeah.
So at C, I'm back at the starting point, just going in the other direction.
Mhm.
Just
Sorry,
got-
we're still complaining. What? Sorry, not complaining. Explaining. Explaining. Why do you have to?
Oh, the
Complain a
fucking
lot,
six.
though, he do.
I'm sorry, I did not mean to say that. I mean, is there two, zero? Like, is the ground considered a starting point? Well, I know it's not a starting point in this problem, but is there technically two zeros?
All right,
One is a starting point.
yes.
Okay.
And position and displacement depend upon two different zeros.
Okay. That doesn't matter, does it?
No, it's a matter of vocabulary, just understanding what position is versus displacement. Displacement cares about starting point, position cares about the origin. And I arbitrarily decide where I want the origin to be. Now, some say, I might have done this before, but some say that the sillier the memory trick, the more apt you are to remember it. Think Ocean Pacific. Position cares about the origin. Or, for the Andy Griffith Show fans, the kid Opie. Or for Bloom County, no wait. Was it Bloom County with Opie or was it Garfield? Either way. Post office, for those people who are civil servants. Position is related to the origin.
Okay.
Oh, I think we pretty much answered this. So after C, through D, and D is included, D is part of the problem, so it has to go somewhere.
Wait a minute. Did that change that was change in position?
That's change in position. Because I start here, I end here, so my displacement, my overall displacement is on, I went down. I'm below where I started.
That's what.
So when you're doing displacement, would it always be in pairs like that?
Oh, then will there always be two of them?
Yeah, like how like in the negatives, we have like C to D, that section's the negative part. Will it always be like in a pair, like a start and the end?
The positive and negative, yeah, I think they'll always have to have at least one pair there. There's always some range, whereas zero is a very specific location. So I could come up with something, but I haven't done it where this was more than just a point in time. Or 2 points at specific points in time. Dana, were you asking a question? Okay. Other questions right now? Kimberly?
Is the C in the parentheses or is the D is just in the bracket?
Yes. And that's just saying that I'm not including C over here, but I am including D. So over here it's reflecting the fact that D's got a negative sign. C is zero, so just past C, I'm at negative. The biggest mistake I see students make is they mix them up. The second biggest mistake is when they get to this, when you get to that last problem on the first test, the origin and the starting point will not be the same thing. I will guarantee you that. These answers are not the same across the board. And so I have some students who I think are playing the game of, I can't remember which one's which. All right, I know one of them is relative to the origin, so why don't I just put that same answer down for all the way across the board, hoping to get at least something. And you know, what I do on that case, if you have the exact same answer all the way across, I grade them both. I take the one you get more points for, and the other one I give you 0, they're partial. Because what you're saying is, I don't know the difference between the two. So just make something different. All right, we're about to do velocity. Questions before we start velocity? Oh, yes, Luis.
For BC right there, it's positive, isn't the ball going down? So
It is, but the displacement, the overall displacement,
Oh,
it's still on the, I'm still above, even though I'm moving down, I'm still above my starting point.
okay.
The part that you just talked about there, that gets reflected in velocity. Yes?
What did the brackets mean?
The bracket means I'm including that moment in time.
Okay,
Parenthesis means it's just past that or just before that.
okay. Thank you.
Velocity. Where is the velocity 0?
It's not, is it?
Sorry, where?
Is the velocity not 0?
It's moving, so it's not 0 everywhere.
Maybe.
Or did you say at the bottom?
I thought I said that, I didn't think it was 0.
Okay. Oh, at no point it's 0.
Yeah.
Is it not A? Is it not?
No, it's already, if it's the 0 at A, the thing's just gonna fall. It's not gonna go up at all.
Right. Sorry.
So maybe B?
All right, so we got B versus never. Is it 0 at B or not?
For a moment.
Pardon?
It's for just a tiny moment, isn't it? Because in order to change the directions, you have to.
Yeah. If you're changing direction, you have to stop for a moment. So B is indeed, velocity is 0. And it is just very briefly, because again, B is just a moment in time. It's a very, whatever the smallest unit of time there is. And this brings up, well, you see it here for velocity. And despite what some students have said on tests, you cannot go from positive to negative without going through 0. Just likewise, you can't go from negative to positive without going through 0. So if I got positive here and negative there, I gotta have a 0 somewhere in between. There's one exception. Well, 2. The one exception that my students have faced is the fact that I screwed up on one of my problems a couple of years back. And I actually set it up so that I defined one of my times wrong. The other time is if there's a rip in the space-time continuum. And that is well beyond the scope of this course.
I don't think that's allowed. Generally.
Not in physics 110. We'll just go ahead and make that claim. We will not allow rips in the space-time continuum. Sort of. All right, anyway. So when is the velocity positive?
A and B.
Yep. So over here, I put a bracket on A because it's going up at A. Parenthesis on B because it's 0 at B, so I don't want to include it there. So I got plus 0. When I hit 0, well, it's either going to become positive more, it's like you're moving in a certain direction, you stop for a moment, and then you keep moving. Or it changes direction. What happens at B?
Change direction.
Which means my sign's going to flip. Or look at it from the point of view as, after the peak, it's falling, it's going in the negative direction. D to D.
So you wouldn't have to include C there?
It's understood, if I got B, D like this, the C's automatically in between it. So the parenthesis or bracket, I guess we saw it there too. If I got A and C here, that includes A to C and anything in between.
Okay.
Yeah.
Why did we not include a bracket under, displacement at the A? Is there a reason?
Or it's like, because it was 0 at A.
Oh,
If I put a bracket there, I'm saying it's 0 and positive at the same time. And again, we're just flat out saying it cannot be two places at once. In physics 110. In quantum physics, that's a place where that is potentially possible.
So it's not slowing down as it's going down after B. Why are we making it negative? I thought it was supposed to be positive.
The velocity? The sign of,
Never mind.
okay. Were you thinking ahead to acceleration?
Thing.
Yeah, that acceleration's the tough one here. Any questions before we hit acceleration? All right, acceleration. As the ball is going up, the velocity is positive, at least that's what we claimed over there. Ball's going up, velocity is positive. Is speeding up or slowing down as it goes up? I hope that's everyone's experience there.
Slow down.
So therefore, the acceleration is, okay. So while it's going up, it's negative, so that's at least there and there. As it's falling,
Speeding down.
it's gonna speed up due to gravity.
okay, it's speeding up.